Hi guys, Ms. O'Connell here. So I'm just going to review quickly the results from the lab. If you did not get these results, please go back to classroom and make changes to your data table as well as your responses to the analysis questions. So we're just going to spend a little bit of time reviewing the data and what that data means from the lab. It was technically due yesterday. Okay, so in our simulation, we see that we can change a few variables. According to the directions, we are asked to change only the radius. Our job is to either decrease or increase the radius. So I chose consistent values. In my example video, in which I demonstrated how to do the lab, I started out with a radius of 20, or 30 rather. So I started out with a radius of 30. I calculated the circumference, right? I took 2 times pi times 30 to get the circumference of 188.5 meters. I then used a simulation to determine what the velocity is. If you're changing only the radius, you notice that the actual magnitude of the velocity does not change, and the vector length does not change. As I increase the radius, the speed, the magnitude of the velocity, remains 20 meters per second. The actual length of the vector, the tangential velocity, does not change. Okay, same if I increase to 30, 40. The actual speed does not change. A good analogy for this, okay, let's say that you can run a 9-minute mile. Okay, so that's the fastest that you can run, a 9-minute mile, and you run 9-minute miles. So when you're running 1 mile, you're going to complete it in 9 minutes. If you increase that distance to 2 miles, you're going to complete it in 18 minutes. Your speed is still 9 minutes per mile. That's not going to change if the only thing that's changed is your distance, right? So you're still going to have the same speed. You'll still run 9 minutes per mile, or 1 mile in 9 minutes, however you want to think about it. That's still your speed. When you increase the distance, it's just going to take you more time to complete it. But your speed will not change unless other variables and factors change. So you should notice why the speed stays the same when our radius changes. The time it takes to complete the circle, or to complete the circular path, increases. So as the circumference increases, the period increases, but the speed stays the same. Okay, so if you're going to run a further distance, it's going to take you a longer amount of time, but your speed can still be constant. So the purpose of this activity was to prove that, right? The definition of uniform circular motion is an object that moves around a circular path at a constant velocity. That velocity is tangent to the circular path. So if we change the radius, the speed stays the same, but the amount of time it takes to complete that circular path will vary. Okay, so we're going to use this data, right? As the radius increased, the tangential velocity remained constant. Okay, and you want to use data. Data means numbers, so you would need to use data. So I will give you an example. Explain how the radius of the circle impacts the tangential velocity of the object. As the radius of the circular path increases, okay, you want to explain what you noticed. This is proven as seen in data table 1. When the radius of the circular path increased from 30 meters to 40 meters, the tangential velocity remained a constant value of 20 meters per second. Okay, you want to use that data again to explain how you know that this object is moving with uniform circular motion. So based on the definition of what uniform circular motion is, which you should have written down in your notes by now, we've reviewed it several times at this point. Based on what the definition of uniform circular motion is, explain whether this object in the simulation moves with uniform circular motion. How do you know that? Based on the simulation and the data. Okay? The extension questions. Okay, so these are going to take a little bit of thought, okay, a little bit of critical thinking on your end. You can use a simulation to help you answer these. So if an object moves in a circle at a constant speed, its velocity vector will be constant. True or false? Explain your reasoning. So I want you to consider what the difference between speed and velocity is. Think about which one's a vector versus a scalar. Which quantity relies on direction? So if the speed is constant, will the velocity vector be constant? True or false? And explain. Are speed and velocity the same thing? Okay, and then take a look at the actual vector on the simulation. Looks like the length is constant, right? Is the direction constant? Okay, so explain your reasoning there. Okay, extension question number 2, explore the quantitative dependencies of acceleration upon the speed and the radius of the curvature. Then answer the following questions. Okay, so from data table 1, we kept the speed the same, basically. Okay, so we increased the radius. Okay, and we kept the speed constant. So when we did that, okay, it gives you the acceleration value on the screen. So you'll have to head back to the simulation. As radius increases, what happens to the acceleration? As radius decreases and speed stays the same, what happens to the acceleration? Okay, number 2, part B. For the same radius of the curvature, the acceleration of the object blank varies blank with the speed of the object. So for this one, you want to keep the radius the same. So you'll set your radius to a specific amount. I'm going to say 30. And I'm going to change my speed, and only my speed. So we're going to note, how does acceleration change when radius is constant, but speed changes? Part C, it's asked if you doubled the speed, what happens to the acceleration? So it kind of piggybacks on part B. And D piggybacks on part B. So C piggybacks on part A and D piggybacks on part B. So when speed's doubled, radius is doubled, what happens to the acceleration? Okay, so you should be able to use your answers from A and B to kind of help you answer C and D. And the options are in these parentheses. So directly, inversely, 1/4, 1/2, 2 times, 4 times. You can either bold that answer or erase all of the terms that are not correct. Up to you. Okay, so that's a nice little review of the lab. So if you had any issues collecting the data or had questions, okay, please go back and make changes to your lab and resubmit it. It will obviously not be late if I'm telling you to resubmit it. So please make changes accordingly if you had issues. Okay, so in addition to this lab, I had some people email me about their simple harmonic motion quiz. So if you did get below a 70 on that quiz, you may need corrections for credit on the simple harmonic motion quiz. So that will be one of 2 quiz grades for the whole marking period. Okay, so if you didn't do or didn't perform as well as you'd like to, okay, you can do corrections on that assignment and get those to me. I need them by June 1st. So your goals, right, for today, fix your lab if you had any issues with it, corrections on the quiz, okay, if you got below a 70, and then there's one concept builder in classroom that's based on a completion grade. So that is all that you have to do. If you have any exams today or tomorrow, good luck. And I will talk to you guys again on Tuesday. Okay, so tomorrow is technically a half school day, but we will not be meeting. As long as you complete this assignment today, you will not have an assignment tomorrow. All right, I will have extra help today after school, as per usual. If you have any questions, just let me know. Have a great weekend.